So today is Sunday, and I have been reading my graphics file format book, The Encyclopedia of Graphics File Formats, second edition. Now, this book is out of print. It's a very old book, and a lot of the information no longer applies, but the majority of it does, because the graphics file formats themselves are immortal, basically, because they store pixels and the colors of pixels and width and height of the image. Like all the bitmap file formats contain similar data, and so they remain the same while operating systems are updated, video games are updated, graphics programs themselves are updated. The graphics file formats themselves stay the same. And it is this stability of graphics that I like, because there may be differences between applications and formats on how the data is stored, but they all have certain things in common, because a graphics file format is about displaying a picture. And as you well know, a video is just a series of pictures played very quickly. So here's the thing. People, if they follow my Facebook page, they have seen that I have taken videos from my Nintendo Switch, because it lets you upload things to Facebook. So then I download those videos off of Facebook, and then I extract, using FFmpeg, all of the frames from that video. Then I use my programming skills to change the colors in every single frame. And this is an example of something that you have to use computer programming for. There's no other way around this. Because you can for a single image, you can open it up in GIMP or Photoshop or whatever, and you can change, let's say you want to change all the red values to green. You can do that on an individual image basis. However, it will take you it'll probably take you at a minimum 30 seconds to do it for an image. That is, if you have a fast computer, the image loads up into the graphical application, you know where the menu settings are, you know how to do it, and then quickly save the new file. So it'll take you probably 30 seconds to do that. However, to do that hundreds or thousands of times could take you all day. My programs that I write are kind of custom coded for each individual purpose. Basically, I have a video file, and I use an FFmpeg command. I have commands saved in text files that I frequently use, and I wrote notes to myself telling me what these commands do to extract all of those frames into a certain format. But usually I use the Windows bitmap format because it's old, because I have written extensive code to load this format. I can't read every single format with my own code, but usually I just output them as 24 bits per pixel Windows bitmap files. So I already have code for that, because that's the easiest one to read, in fact. Oh, and a little bit about that. When you have a file format that stores the red, green, and blue values as bytes that range 0 to 255, though that is the easiest format to read. And why is that the easiest format to read? Because you don't have to use any advanced bit shifts. I do use some bit shifting in a lot of my functions, but basically, here's how it works: is you only need to read the individual bytes using, fgetchar or whatever, something like that, in the C programming language. But of course, that's programming language specific. But anyway, I already have a function that can read this format. So it reads that format into an array of pixels. And I use C code for what I do. And then I have other functions which change the number of colors. I have a function which can change the colors automatically to be a subset of the original colors in the image. I have a few functions I've written recently that will create a new bitmap file, but it will reduce the number of colors. For example, I can take a 24-bit bitmap file that contains thousands of colors, and then I can use this one function I wrote that converts it to 6 bits per pixel values and stores, it's 8 bits per pixel how it stores it, but it uses a palette of only 64 colors. And it uses, basically it's only using 6 bits. And it's actually, there's a very simple method of how I do that. And that method of changing those colors does involve bit shifts, because here's what you do is, you take the red, green, and blue values, you get those numbers, and they'll be 0 to 55, and then if I want 6 bits per pixel, I'm only going to use 2 bits from each of the red, green, and blue values. So I use the high order bits, so the highest 2 bits in the byte. So basically, I will be shifting the bits, but basically I'll be shifting it 6 bits to the right, so that it will always be a number ranging from 0 to 3. It'll only be using 2 bits. But then I have other code that bit shifts it so that it creates an index value. And it's really brilliant. It took a long time to do, because I'm that kind of person who will spend 3 or 4 hours writing a function to do a very specific thing. So all of my code is specific. It's very specific. It's like the frames of this video are in this folder. It will read them in this order using the numbers of them, and then it loads those, and then I have this function that's specifically designed to convert the colors into a very specific subset, creating a palette and everything. And then it either overwrites those frames in the original folder, but what I like to do is I like to read the frames from one folder. I have a very specific folder on my hard drive where I read them from. And then I have another place where I have it write the output frames. So that way I can always reuse the original frames from the video. And I've even figured out how to include the original audio from the original video in it. And so I've done that with a lot of my Nintendo Switch videos. And it works with any video, in fact. In fact, I may show more examples of this in the future, because it's totally possible to take even this video, or any of my videos on my YouTube channel, and then reduce the number of colors in them so that it shows something. You know what? I'm going to turn on some light. That doesn't make much difference. Whatever. But see, here's the thing. So I've done a lot of programming, but my binary bitmap project, which also will extend to the binary gray map and the binary pixel map projects, it started out as me designing my own format. And this book, you have to buy a used copy, because they don't make these anymore, because it costs a lot to print this book, because this thing is as big as a phone book, and I have Kleenex in my favorite pages as bookmarks. So this book, it would take me like 50 years to read it straight through. I have been going to the specific sections that I'm interested in. Now let me go to page 139, because I should have a Kleenex in page 139. But I have so many Kleenexes, this is getting crazy. I need a better bookmark system, but the problem is I would still be inserting like 15 bookmarks into this book. I need to find some simpler way to do this. But you can read this book digitally online. There's a website where you can read it in HTML format. But that I don't like that. I like to have an actual book. I'm old fashioned. So, here I want to read from this page, designing your own format. We find it hard to imagine why anyone would think the world needs another graphics file format. And in fact, we don't want to give the impression that we're encouraging such behavior. But given the fact that people can and will create new formats, we'd like to leave you with some pointers. You know what? That's very interesting. But anyway, why even consider it? The truth is that this book does not even begin to include all of the hundreds of more obscure formats, some of which are used only privately and remain inside company walls. Companies wishing the output of their products to remain proprietary will always find a way to make it so, and thus will continue to develop new formats. Designing your own format also will help you avoid legal trouble should the use of someone else's format one day be restricted through legal action. The use of the GIF file format has recently come under licensing restrictions requiring that a royalty fee be paid for software that reads or writes the GIF file format. Payment of this fee has been actively enforced through the threat of legal action both by the owners of the GIF format and the owners of the Lempel-Ziv-Welch LZW compression algorithm used by GIF. Remember that even though many formats appear to be freely and publicly available, very few actually are. Of course, there are functional reasons for designing your own format. You may decide that an appropriate format doesn't yet exist, for instance, and thus feel compelled to create a new one. Reasoning leading to this decision is always suspect, however, and sending yet another format out into the world might even decrease your market share in this era of increasing interoperability and file sharing. The unfortunate reality is that file formats are usually created to support applications after the fact. In the modern world, marketing decisions and speculation about the future evolution of the supporting operating system and hardware platform play large parts in the development of program specifications from the very start. So we urge you to consider designing your application around a set of existing formats, or at least a format model. And then it goes on to several tips for if you do decide to create your own format. But I wanted to read that because I have a lot of things to say about graphics file format and why I chose to create my own format, which is not complete. Now, I did create the binary bitmap format, and I have some code that reads and writes it. And I also had started on the binary pixel map format, which was designed to be based around red, green, and blue values. But I kept running into this major hurdle where I wanted to decide on the format, exactly which bytes of which address in the file will decide which data. And the reason there are so many graphics file formats, in fact, there are over 500. There's even a program, I believe it's called XNView. I have that installed that can view over 500 different file formats. There are that many image file formats, and let's not even get started on audio and video. And video is an extension of images anyway. But so here's the thing, is that there are so many formats because nobody can agree on the best way to write a graphics file format, and so everybody creates their own. Well, this it has deep psychological implications. First of all, if you've noticed anything about humanity, humanity cannot agree on anything. Look at how people fight over politics and religion and even computer software. I mean, there are people who will fight with each other over even things about Minecraft, and people argue about which is the best programming language, of course. And of course, the simple answer, this is obvious: use whatever you like, use whatever you prefer that meets your needs. When it comes to the computer world, that's what you do: play the games you like, use the graphics programs you like, use the word processor you like, do whatever you like, use the programming language that you like. Now, if you are a software developer trying to get into the programming world, don't. I've read so many horror stories of people who try to get a paid professional job as a computer programmer, and you don't want to do that. That is, unless, of course, you're Notch and you create the next Minecraft and you're an independent developer and you make millions of dollars. If you're a skilled game programmer, go that route, but don't work for a company or a boss. Don't do that. In fact, I disagreed with his decision to sell the rights to Minecraft to Microsoft, but that's what he wanted to do, and he ran away with a lot of money. Anyway, but this isn't about Minecraft. Anyway, this is about, first of all, people can't agree on anything. Second of all, each person has a very specific purpose when they create a new format. Now, in this video, my main purpose of this video, which I'm finally getting to, and it's almost 17 minutes into this video, which is embarrassing because I ramble, is the reason I decided to create my own format. The primary reason was as a learning experience, because when you are trying to learn how to become a better programmer, and in my case I'm using the C programming language, although I've dabbled with several languages, you need an experiment, you need a test project. I've tried game development, I'm horrible. I've tried various different interactive programs. I even wrote a calculator a long time ago. I don't even know if I can find the code for that anymore. But it was a text-based calculator anyway, and it wasn't any better than any existing one. So, as a programmer, I'm basically a hobbyist programmer. I've always had this dream of doing something that nobody else has done before. But the problem is there are billions of humans in the world, and no matter what you try to think of, somebody else has done it before. Unless of course you're the creator of Minecraft, like I said before. But anyway, back to the point is, when somebody does graphics programming, they have to know every detail there can be about a programming language. I'm not kidding. I've done many things. I've done, powers of two programs that produce integer sequences, and even those require a lot of knowledge. You have to know about variables and loops and arrays sometimes, and you have to know while and if. You have to know all the fundamentals of programming to even do a program that displays an integer sequence. But graphics programming takes it to a whole nother level, because you have to know very, very specifically how to do things like reading and writing files. So how to open a file, how to go to a specific address of that file, read a specific number of bytes from that file, and then to write it to another place or to do something in your program with it before you write it to another one. So I've succeeded. I've done it. I have a mountain of code. I have probably 12 to 14 files of source code on my computer that I frequently back up to my SourceForge project and my email accounts. And the code is scattered, and I'm still years away from being able to publish it. The code's messy. It needs comments added, comments removed, and descriptions of what the variables actually do. So I've recorded several programming videos on my YouTube channel, but people don't understand this stuff no matter how hard I try to explain it, because first of all, here's the truth is, if you want to be a programmer, you kind of have to be a nerd. You have to love math. I think so anyway. You have to love math. You have to be willing to spend hours upon hours in front of a computer trying out things and wondering why your code is not working, which has happened to me so many times. But anyway, programming is hard, but I have succeeded in a lot of my goals. The very fact that I can take videos and other still pictures and then do stuff, and I've drawn checkerboards. I have a very specific function called Chastity Checkerboard that I wrote that specifically writes a checkerboard to an image. And I've probably used that function more than any other function, and it's kind of a play on words, because chastity means celibacy, but it also means purity. So I call it the pure checkerboard, basically. But anyway, so yeah, I can write checkerboards. I can load other image files and manipulate the colors and then make a new video out of them. So I have succeeded. I have done it. But what I have not succeeded yet in is the original goal that I started with, which was designing my own format. And by the time that you're watching this video, I may have already solved this issue. But it's not a real problem, because this is volunteer work. Whether or not I ever finish my graphics file formats that I load and save, or maybe write an image converter for, doesn't matter to the rest of the world. It matters only to me. And that's what's great about this programming project, is there's no pressure. If I want to put it off for 6 months and then work on it again, I can do that. You know what I mean? But the decisions involved in designing your own format are numerous, because you have to decide what type of data will my format support. For example, my binary bitmap format that I currently have, it stores the width, the height, the number of bits per pixel, and a pointer value. And the current state of this format, which may be final because I really like the way it works, is the first 4 bytes are the width, horizontal distance, that's the width of an image, and then the height is obviously vertical, up to down, and then the number of bits per pixel tells how many bits it takes to store each individual pixel of the data. And the most common ones I use are 1 bit per pixel for just black and white images that I do, or 24 bits per pixel, which basically can do pretty much all the colors. And I have worked on supporting a subset of grayscale, so 2, 4, and 8 bits grayscale, so it ranges within a spectrum of black to white. And so here's the thing is, this format that I currently have was heavily inspired by the Windows bitmap file format. Now here's the difference. My format is a little bit better. It's not complete, the code isn't complete, but the design of the format is already better than Microsoft design of the Windows bitmap file format. And here's why. Because that format, it stores 14 bytes in the bitmap file header, and that doesn't even include the width and height. It's just like a bunch, like to the file type identifier and some reserve values for future use, and then it contains the pointer to the pixel data in that header, and that's where I got the idea for the pointer. But then, additionally, it has the device-independent bitmap header, and there's several different versions of the DIB header, and of different sizes, and that is what contains the width and the height and the bits per pixel. And it also contains additional information that most of the time is not used, like the number of color planes, which is always 1. And it's always 1, so why even store it in the format? However, the reading and writing that format in my code gave me inspiration of how this should work. So the minimal amount of when I output a Windows bitmap file format, it has 14 bytes of the file header, and then it will have 12 bytes of the DIB header. So that's 26 bytes, and it hasn't even described any of the pixels. And the pixel data comes after a palette, the palette data, if the palette exists in the file. So in other words, Windows bitmap file formats are huge. They're huge in file size, both because they're typically uncompressed, although they can be compressed. But also they're huge because it has a 26 byte header and sometimes a palette included in the file. So what ends up happening is several kilobytes of space are wasted when you're doing multiple image frames. So there are inefficiencies in this format. So I decided to design a new format that contains the width, the height, the bits per pixel, and a number that is a pointer to where in the file the pixel data starts. And the reason I decided to include the pointer rather than just having the pixel data start immediately after the other values was because basically you can include comments in my format. So in other words, because it has a pointer to the pixel data where the image data will start, where the pixel colors are stored, I can have a comment after that. It can be text, it could even be the whole contents of another file in between the header and where the pixel data actually starts. And of course, you can also include any data after the pixel array, after the pixel data, and it won't read it, because my functions are designed to only read all the pixels based on the width and height values, which, the width times the height equals the number of pixels in the image. So basically, it's possible to include comments. I could include copyrights in my format. I could include a signature that identifies who I am or what operating system or which version of my software is contained in it. Now, the TIFF file format, the tagged image file format, contains specific fields for all that data, and it's very cool. I like the TIFF format, but it's too complicated and it's a waste of space because it contains data that's not even needed to display an image, such as the printing resolution, which only matters if you're printing it. But anyway, back to the Windows bitmap file format. It's great and it works. Many games use the Windows bitmap file format because it's old, and if it works, why change it? But the long story short, I decided to design my own format, both as a learning experience of seeing what it's like to be a graphics programmer and read and write files, but also to save space, because if I have if I have a video that's 1 million frames and I'm going to be extracting all of those frames, there's going to be so many megabytes of wasted data by the file header of the other formats. Whereas my format only has a 16 byte header instead of something like a 26 byte header. So I'm saving 10 bytes. That may not seem like much, but to me it matters a lot, because I like saving space, but I also like the experience of learning graphics file formats. So anyway, that's what I wanted to say, and that's my nerd rant. I hope you've enjoyed.